to the next one, sodium oxide. So sodium oxide, the symbols or the formula of the elements present here. One is sodium, which can be represented as Na. One more is oxide, this is oxygen, which can be represented as O. Now valency of sodium is 1, valency of oxygen 2 minus, that is 2. Interchange, so the formula can be written as Na, this 2, and O, this 1. We are not writing 1. Na to O. So you have to remember N capital letter, A small letter, sodium symbol that, Na, O capital letter, symbol of oxygen. So NaO, that is Na to O. Come to next compound, calcium oxide. Symbols of the elements present. Symbols of the elements present. One is calcium, another one is oxygen. Symbol of calcium, capital letter C, small letter A. Calcium can be represented as Ca. Oxide, oxygen can be represented capital letter O. Now come to the valency. Valency of calcium is 2, as well as valency of oxygen is also 2. So this 2 goes here, this 2 goes to oxygen. Formula Ca2O2. But you have to simplify here. If they both the atoms, if they get same number, you have to cancel that. This 2 gets cancelled, and the formula will get CaO, calcium oxide. You can cancel, so cancelling can be done only if you get same number here. So it is CaO. Now we will move to the next compound, that is aluminium chloride. So symbols of the elements present here. One is aluminium, another one is chlorine. Aluminium can be represented as Al and chlorine is Cl. Aluminium valency of aluminium is 3, chlorine is 1. Interchange. So formula can be written AlCl3, aluminium chloride. Last one is sodium sulfide. The elements present, symbol of the elements present are, one is sodium, which can be represented, sodium can be represented as capital letter N, small letter A, sodium, natrium. Sulfide, that is sulfur, yes. Sodium valency of sodium is 1, valency of sulfur is 2, cross interchanging. So formula is Na2, yes, sodium sulfide, formula of sodium sulfide. In this way we can write the chemical formulae of different compounds. So I was discussing about formula unit mass. Calculation of formula unit mass is same as that of the calculation of molecular mass. So we will calculate the formula unit mass of these compounds. So the question is, calculate the formula unit mass of zinc oxide, sodium oxide and potassium chromate. Atomic masses of zinc, sodium, potassium, carbon and oxygen is given. So we will calculate the formula unit mass of first one, zinc oxide, ZnO, zinc oxide. So first it is same as calculation of the molecular mass of zinc oxide. How to calculate molecular mass of zinc oxide? It can be calculated as, this is two elements present here are zinc and oxygen. Only one atom of zinc is present. So 1 into atomic mass of zinc. Atomic mass of zinc plus 1. Only one atom of oxygen is present. So 1 into atomic mass of oxygen. which is equal to 1 into atomic mass of zinc is 65 atomic mass unit plus 1 into atomic mass of oxygen 16 atomic mass unit, which is equal to 1 into 65, 65 plus 1 into 16, 16, which is equal to 60. 6 plus 5 11, 1 carry, 6 plus 1 7 plus 1 8. So 65 plus 16, that is 75, 80, 81, 81 atomic mass unit, 81 U. We'll move to the second question, second compound, which is that second compound, that is Na2O, sodium oxide, Na2O, which is equal to, here you can see in the formula, 2 atoms of sodium is present here. So I can calculate molecular mass as 2 into atomic mass of sodium plus only one oxygen atom, 1 into atomic mass of oxygen, which is equal to 2 into sodium atomic mass how much? 25 plus 1 into oxygen atomic mass 16, which is equal to 25 into 2 50 plus 16, that is 50 60 66 atomic mass unit. Now we will move to the third one, that is K2CO3, which is equal to 2 molecules of potassium, 2 into atomic mass of K, potassium, plus C, that is carbon, 1 into atomic mass of carbon, plus third element oxygen, that is 3 atoms of oxygen, that is 3 into atomic mass of oxygen. Substitute, which is equal to 2 into atomic mass of potassium is 35 atomic mass unit plus 1 into carbon is 12 plus 3 into oxygen is 16, which is equal to 39 into 2, 9 2s are 18, 1 carry, 3 2s are 6 plus 1, 7, 78 plus 12 plus 48, which is equal to 8 plus 2, 10, 10 18, 8 1 carry, 8 plus 1 9 plus 4 13, 138 atomic mass unit, 138 U. So calculation of atomic mass unit, calculation of molecular mass and the calculation of formula unit mass. The method is same. For both the method is same, but you should know the atomic masses of different elements. If the atomic mass is given, you can easily calculate formula unit mass of the given compound. There is a question in your exercise. Question is, name the elements present in the following compounds. So to write the elements present in the compounds, first you should know the chemical formula of these compounds. So first one is given quicklime. Quicklime is nothing but calcium oxide. Quicklime is calcium oxide. So the formula of quicklime can be written as, its chemical formula can be written as CaO. CaO is the chemical formula of quicklime. It is calcium oxide. Now, see what are the elements present in this calcium oxide. You can see in here Ca. Ca means calcium and O is oxygen. So which are the elements present in quicklime? Elements present are one is calcium and one more is oxygen. Calcium and oxygen. See the second one, hydrogen bromide. Hydrogen bromide, the formula can be written as HBr. Hydrogen bromide, HBr. So which are the elements present in this formula? Which are the elements present in hydrogen bromide? Elements present are only two elements are present here. First one is H. What is H that? H means hydrogen, and second one is hydrogen. Which is the second one? Br. Br is bromine. Hydrogen and bromine. Now move to the third one. Third question given in your textbook, that is baking powder. Baking powder. Baking powder, which is used in bakeries to make bread or cake soft. Baking powder. So baking powder you have studied in your 8th standard. Baking powder formula. The chemical name of baking powder is sodium hydrogen carbonate. So formula can be written as baking powder NaHCO3. This is the chemical formula of baking powder. Now see the elements which are present in this formula. Na. What is that Na? Na means symbol of sodium. Next is H. What is H? H is hydrogen. Next element is C. What is C? C is carbon. And next element is O. What is that O? O means oxygen. So which are the elements present here? Elements present are, one is sodium, hydrogen, carbon, and fourth element is oxygen. Baking soda elements present are sodium, hydrogen, carbon and oxygen. Now move to the last question which is given, that is potassium sulfate. Potassium sulfate. Potassium sulfate. Potassium sulfate, its chemical formula can be written as K2SO4. The chemical formula of potassium sulfate. I already discussed how to write the chemical formula. Potassium sulfate. Potassium charge is +1. Sulfate SO4 -2. So that 2 goes to potassium. K2SO4. The chemical formula of potassium. So see this chemical formula of potassium sulfate. What are the elements present here? One is K, one more is S, and another one is O. What is K? K is potassium, S is sulfur, and O is oxygen. So elements present are potassium, sulfur and oxygen. These are the elements present in potassium sulfate. To write the elements present in a given compound, easily you can write by writing its chemical formula. It is not compulsory that you have to write the chemical formula. But if you write its chemical formula, easily you can understand the elements present in that formula, and easily you can write the elements present in the given chemical compound. Students, now we will move to the next concept of the lesson, that is mole. So before explaining this mole, we'll take one important reaction, simple reaction, that is the formation of water. So how water is formed? When hydrogen combines with the oxygen, H2 plus O2, we get water, H2O. When hydrogen react with the oxygen, we get water. Balance the reaction. Here two oxygen atoms are present. So here only one oxygen. I write here 2. It will be, when I write here 2, this 2 and this 2, you have to multiply. 2 2s are 4. You will get 4 hydrogen atoms. So in this side only 2 hydrogen atoms are present. Therefore you have to multiply this side by 2. So the reaction is 2H2 plus O2 gives product 2 In the sense, two hydrogen molecules combines with one oxygen molecule. Two hydrogen molecule combines with one oxygen molecule to give two molecules of water. Now we define this reaction in terms of mass. So to calculate mass, calculate the molecular mass of hydrogen and oxygen. You already studied how to calculate molecular mass of the given compound. Here 2H2 in the sense 2 into H2, molecular mass of hydrogen, that is 2 into atomic mass of hydrogen is 1, 2 into 1, which is equal to 2 ones are 2, 2 twos are 4, 4 atomic mass unit, 4U. Now calculate for the oxygen O2, which is equal to 2 into atomic mass of oxygen is 16, that is 32 atomic mass unit, and water 2H2O, which is equal to 2 into H2. 2 into atomic mass of hydrogen is 1 plus 1 into oxygen, that is 1 into atomic mass of oxygen 16, which is equal to 2 ones are 2 plus 16 ones are 16, that is 16 plus 2 18, 18 twos are 36, 36 atomic mass unit. What does it mean? It means 4 atomic mass unit of hydrogen combines with 32 atomic mass unit of oxygen to give 36 atomic mass unit of water. So what does it mean? So mass of a substance, to understand the quantity of a substance, mass of a substance is very important. The quantity of a substance is the characteristic property of any substance. So it can be defined, it can be explained in terms of its mass or in terms of number of particles which participate in the chemical reaction. It may be atoms, it may be molecules, it may be ions, anything. So how many molecules or the ions or the atoms participate in the chemical reaction, or how much mass? So what is the mass of the reactant that participate in the chemical reaction? But when you compare this, usually while writing the chemical reaction, if you write chemical equation of any chemical reaction, we don't write their mass. Just the particles, the number of molecules which participate in the chemical reaction is mentioned. Therefore, instead of explaining the quantity of a substance in terms of its mass, it is more convenient to explain the quantity of a substance in terms of number of particles which actually participate in the chemical reaction, the number of particles. So these particles may be ions or the atoms or the molecules or anything. So number of molecules or the atoms participate in the chemical reaction. Therefore, a new concept called mole is derived or it is introduced. Mole, a new concept called mole. So what is this mole? Mole is nothing but the 1 mole of a substance or 1 mole of any species. Any species, it may be 1 mole of atom, 1 mole of molecule or ion or any particles. The 1 mole of a species. Species in the sense here, it may be atoms, molecules, ions or the particles. So 1 mole of species, any species is that quantity. It is that quantity in the number having a mass equal to the atomic mass or the molecular mass in the grams. So 1 mole of any species, it is that quantity in the number having the atomic mass or molecular mass which is expressed in the grams. If you express the molecular mass or atomic mass in grams, it is called 1 mole of any species, that is called 1 mole. Usually 1 mole which is equal to 1 mole which is equal to, it is 6.022 into 10 to the power 23. 1 mole, which is equal to 6.022 into 10 to the power 23, and this constant, it is a constant value which is called as Avogadro's number. Avogadro's constant or Avogadro's number. So if it's right, how we define 1 dozen? How we define 1 dozen? 1 dozen is equal to 12. 12 may be anything. It may be 12 pencils or 12 erasers or 12 sharpeners or 12 bangles. Anything. It is 12. That is the number. 1 dozen means 12. In the same way, 1 mole. How many particles are present in that 1 mole? 1 mole in the sense, because the atoms or the molecules, they are in the very large number. So we define 1 mole. So what is that number? 6.022 into 10 to the power 23. So this is a constant. This constant we call as Avogadro's number. So you will understand this mole concept in a better way. So mole concept, mole is nothing but how to calculate it. Usually we are calculating molecular mass or the atomic mass, and that is mentioned in the grams, which is called 1 mole. So it is also called molar mass. It is 1 mole, or it is also called molar mass. That is expressed in the grams. And remember Avogadro's constant. The value of Avogadro's constant is 6.022 into 10 to the power 23. So don't get much worries in this. It is nothing but how we say 1 dozen is 12. In the same way, 1 mole is this much. This is the value 6.022 into 10 to the power 23. That constant we call as Avogadro's number or Avogadro's constant. So about this mole, you will understand better while calculating problem, while solving a problem. It will be clear for you. It will be more clear for you. This is your exercise question which is given in your textbook. Question is, what is the mass of 1 mole of nitrogen atoms? So what is the mass of 1 mole of nitrogen atoms? So while defining mole concept, I said it is the atomic mass or molecular mass which is expressed in the grams. So what is the mass of 1 mole of nitrogen atoms? So first write what is this, or you can write it as mass of 1 mole of nitrogen. Mass of 1 mole of nitrogen atoms, which is equal to, what is the atomic mass of nitrogen? Atomic mass of nitrogen is 14. Therefore, here same thing is given, nitrogen atoms. Therefore, it's a mass 1 mole of nitrogen atoms. Mass of 1 mole of nitrogen atoms. In the sense, molar mass of nitrogen atoms is 14 gram. Molecular mass or atomic mass is 14 atomic mass unit. We are writing 14U. But instead of U, if you write it G, grams, it is called molar mass. The mass of 1 mole of the substance, 14 grams. So see the second question, B. Question B in that, what is the mass of 4 moles of aluminium atoms? 4 moles of aluminium atoms. Aluminium atoms, and also it is given inside the bracket, atomic mass of aluminium is 27. So first I write mass of 1 mole. Mass of 1 mole of aluminium atoms, which is equal to 27 gram. That is the atomic mass, which is represented in gram, which is called molar mass. So mass of 1 mole of aluminium atom, 27 gram. Therefore, mass of 4 moles, of aluminium atoms, which is equal to 4 into 27. That is 7 4s are 28, 4 2s are 8, plus 2 10, 108 gram. This is also called molar mass. You are representing in gram. That is the mass of 1 mole of the substance.